Max and Min were getting excited about their birthday party coming up. They had invited 10 friends and were hoping they could all come. Their Nana said she would make one of her famous chocolate cakes for their birthday, or even more than one if they needed it. So the twins started to discuss how much cake they and their friends would each get. "What if none of our friends come?" exclaimed Min, a little worried. "Well," replied Max with a chuckle, "we would get a lot more cake. In fact, cutting the cake into 2 equal pieces for just the 2 of us, we would get half the cake each. But surely at least one of our friends will come, in which case the 3 of us would get 1/3 of the cake each. And," continued Min, "if 2 of our friends come, the 4 of us would eat 1/4 of the cake each. 3 friends and the 5 of us would eat 1/5 of the cake each. 4 friends and the 6 of us would get 1/6 of the cake each." "Yes, Min, I get the idea," replied Max. "What concerns me the most is that the more friends that come, the more fun we have, but the less cake we all eat. Imagine if there were 8 of us, we would only get 1/8 each, and 10 of us would only get 1/10, and if all our 10 friends come, we would only eat a tiny 1/12 of the cake each." "Yes, Max," Min agreed. "The more friends that come, the bigger the denominator in the fraction we each get, and the smaller the piece of cake." Talking about fractions reminded the twins of videos 3.4.1, 3.4.2, and 4.4.1, where they looked at fractions, which are numbers written as a numerator over a denominator, such as 5/12, equivalent fractions, which are fractions that have an equal value, such as 1/3, 2/6, and 4/12, and mixed numerals, which are numbers that combine a whole number with a fraction, such as 3 2/5. They also looked at comparing the size and position of fractions and mixed numbers on a number line. When you position fractions on a number line, you can see which fractions are bigger because they are closer to 1. For example, 1/2 is bigger than 1/3, and 2/3 is bigger than 1/2. And which fractions are equivalent, that is, have the same value. For example, 1/2, 2/4, and 3/6 are all equivalent fractions because they are in the same position on the number line. Max's stomach growled, sending his mind back to his Nana's chocolate cake. "Min, if there are 12 of us at our party, we would definitely want 2 cakes. Each whole cake is 6/6. 6/6 plus another 6/6 equals 12/6. That means each of us will get 1/6 of a cake." Min remembered they had learnt at school that a fraction whose numerator is larger than its denominator, such as 8/5, is called an improper fraction. A fraction whose numerator is smaller than its denominator, such as 2/3, is called a proper fraction. She also remembered that a fraction is a division calculation. That is, the numerator is being divided by the denominator. Min reminded Max of these facts about fractions. So Min, Max said, an improper fraction will work out to be a whole number or a mixed numeral. For example, an improper fraction such as 10/5 will work out to be a whole number because the denominator will divide exactly into the numerator. That is, 10 divided by 5 equals exactly 2. An improper fraction, such as 7/3, will work out to be a mixed numeral because 7 divided by 3 equals 2 and 1 left over. So we get 2 and 1/3. Max likes to draw number lines to help him understand numbers. So to help him understand 7/3 as a mixed numeral, he quickly draws this number line, starting at 0 and marking off 7 lots of 1/3. He can see that each lot of 3/3 is one whole number. So 2 lots of 3/3 is 2, and there is 1/3 left over, which gives us 2 and 1/3. Using the same number line, he can also see that the mixed numeral 1 and 2/3 can also be written as the improper fraction 5/3, that is, 5/3. When you can, review fractions by watching our previous Topic 4 videos. Now you can watch this video again or try the quiz and look at the chart that comes with this video.